So I'm working on a project where I will need to provide a short impulse of about 250 volts. The only problem is that this power supply only goes up to 28 volts, and if I wanted to power it with a battery, the highest voltage battery I have is 11.1 volts. So I found a way to step up DC voltage, because obviously you can't use a transformer like this with DC. That only works with alternating current, aka wall power. So just to explain the setup really quick, this is the capacitor that I want to charge to 250 volts. This is a 9 millihenry inductor that I've made. This is a signal generator. This voltmeter will read the voltage of the capacitor. This oscilloscope will show the signal being generated by the signal generator, and I'll use this one to prove that. Where's my probe? There it is. So this voltage actually gets stepped down from 9 volts to only about 3 volts. And so what I'll actually do is charge this capacitor to well above 9 volts, just so you see that I'm stepping up the voltage. And here you can see my control signal that I can adjust and make it more frequent. So let me turn that all the way up. Take this safety out. So starting at 1.9 volts on the capacitor, once I pull this out, and we're over 9. And it'll just continue climbing. If I were to leave it here, it would continue climbing until the capacitor reached its limit, which is about 250 volts, at which point it'll probably fail. I can also make this charge faster, I believe, if I turn the control signal up. So let's try this. Oh, no, that didn't help. There we go. Yeah, so as you can see, from a 9 volt input being stepped down to 3 volts, I can get a much higher voltage with this boost converter. I'm going to turn it off before it blows itself up. So just to explain how that works really quick, say I've got a 9 volt battery, my inductor, a transistor, my capacitor, and a diode. Now let's wire all these up. Now, as long as this transistor is allowing current to go through it, current is leaving the positive side of the battery and going to the negative side. And while current is flowing through an inductor, it establishes a magnetic field around that inductor. But say as soon as I close this transistor, as in I stop applying a control signal to it, the magnetic field starts to collapse, and in doing so induces a current across this inductor. But because this transistor is open, it can't go to the ground of the battery. So what it does is it goes through the diode and goes into the capacitor. And it doesn't matter what voltage this capacitor is, that magnetic field has got to collapse. There's nothing that can stop that. So it doesn't matter if this capacitor is at 100 volts. This force, this electromotive force, is going to overcome that 100 volts and still pump energy into this capacitor. So if I rapidly turn on and off the transistor, it will continuously make a magnetic field form and collapse and move into the capacitor. So that's what the control signal is for. It's basically continuously turning off this, turning on and off this transistor here, and the capacitor will slowly charge. So pretty handy, I'd say.